about how carbon dating works. Carbon dating is based on the presence of the carbon-14 isotope, which has 6 protons and 8 neutrons. Carbon-14 is rare compared to carbon-12, but is still found prominently throughout the Earth. Carbon-14 is unstable, found in all living things, and is radioactive but not dangerous. Carbon-14 is produced through the process of cosmic radiation bombardment. In this process, cosmic ray protons break apart nuclei in the upper atmosphere. After this, neutrons from these nuclei bump into the nitrogen-14 isotope until carbon-14 is produced. Then the carbon-14 oxidizes with oxygen in the atmosphere, becoming carbon dioxide. This carbon dioxide can then take carbon-14 into the food cycle because plants need carbon dioxide for photosynthesis. In this way, carbon-12 and carbon-14 is consumed by plants and animals through natural processes like breathing and eating. So we can assume that the ratio of carbon-12 to carbon-14 in biological organisms is equal to that of the atmosphere, because while living things are alive, they are constantly replenishing their carbon-12 and carbon-14 levels by eating and breathing. Carbon-14 is radioactive, which means it has the tendency to decay. Its half-life, the definition of half-life first, is the time it takes for 1/2 of the atoms of an unstable element or nuclide to decay radioactively into another element or nuclide. So this means that over time, carbon-14 decays back into nitrogen-14 in 1 electron, and because it is unstable. However, carbon-12 does not decay because it is stable. So this means that if you found a fish that died about 5,000 years ago, the carbon-12 levels in that fish will not have changed since carbon-12 does not decay. However, the carbon-14 levels in that fish will be about half of what they should be, because half of it will have decayed after about 5,000 years. Because it's unable to replenish its carbon-14 levels by breathing and eating since it has died. So, using the ratio of carbon-12 to carbon-14 found in a sample, you can find the age of the sample. So in the atmosphere today, there are 1 trillion carbon-12 atoms to 1 carbon-14 atom. So if you found a sample that had 2 trillion carbon-12 atoms and 1 carbon-14 atom, you can infer that the sample is about 5,730 years old, since the carbon-14 level is about half of what it should be, taking into account this ratio of 1 trillion carbon-12 to 1 carbon-14. So then you can infer that one of the carbon-14 atoms has decayed back into the nitrogen-14 over time. However, the carbon-12 level is the same as when the sample died. Scientists use a variety of methods to find the amount of carbon-14 in a sample in the first place. They use gas proportional counting, liquid scintillation, and accelerator mass spectrometry, all to find the amount of carbon-14 in a sample. Thanks for listening.